Welcome to video 5.3 in our first Principles of Astrophotography series. In this video we discuss narrowband filters that are used to gather light from specific wavelengths of emission nebulae.
This video is based on section 5.3 of our first Principles of Astrophotography book, which is linked in the description below. I'm Ren Edwards.
And I'm Boyd Edwards.
Let's talk sensibility. Alright, Principle 87. Narrowband filters. Narrowband filters pass a narrow range of wavelengths centered on one or more emission lines. Principle 88. Narrowband SHO filters. Sulfur-II filters target the average of the 671.6 nanometer and 673.1 nanometer lines. Hydrogen alpha filters target the 656.3 nanometer line, and oxygen-3 filters target the 500.7 nanometer line.
So in chapter 4 of the book, and the videos 4.3 or 4, somewhere along in there, we talk about these various lines, where they come from, and the hydrogen alpha is the strongest of the hydrogen Balmer lines, and that one's targeted by the so-called hydrogen alpha filter. Shown here are the spectra, transmittances actually, of chroma 5 nanometer filters. So let me be clear about that. By 5 nanometers, I mean the full width at the half max of this hydrogen alpha filter is 5 nanometers. So that's a hydrogen alpha, and it targets that line. It ignores the hydrogen beta and the hydrogen gamma lines. The oxygen-3 filter, so this is the transmittance curve of the chroma 5 nanometer oxygen-3 filter, and it targets the 500.7 nanometer forbidden line of oxygen, like we talked about in chapter 4. It ignores this 495.9 nanometer line. I imagine there are some oxygen filters maybe with a broader passband that would include both, but we're talking about 4 nanometer difference between those two lines. Well, that's not a very big difference. So maybe if you had a 10 nanometer bandwidth filter, you could get some of that other oxygen-3 line. Yeah.
Pretty weak still, but yeah.
Yeah. Doesn't contribute as much. And then finally, the sulfur line, sulfur filter.
What sulfur line?
Yeah, there ain't nothing here, right? Is that what you're saying?
Yeah.
Yeah, there's nothing, which is an important thing to point out here. The OIII Nebula is a standard diffuse emission nebula, diffuse nebula. Doesn't produce much sulfur. So here's the ring nebula, M57. Also has some H alpha, some oxygen-3. Shows a little bit of sulfur. So these two lines, as you remember from chapter 4, are very close together. They only differ from each other by 1.5 nanometers. So as we talked about a couple of slides ago, the manufacturers target the average of those two wavelengths and try and capture them both. No reason not to, because there's only 1.5 nanometers between them. Then for the Crab Nebula, we talked about this one. These sulfur lines are quite strong, and the reason is that the rapid expansion that we talked about in a previous video of these supernova remnants are ramming into, it creates a shock wave as the remnants run into the interstellar gas, and those collisions excite those sulfur lines. You'll see sulfur in supernova remnants. On the other hand, based on this slide, if you spend some time, if you have a monochrome camera and you want to take, or even a one-shot color camera, if you're trying to get sulfur from the OIII Nebula, you're not going to get much. It's probably not worth your time.
Mm-hmm. So it's a good thing to know to know how to spend your time, especially if you're doing monochrome on an object.
So for example, if you have the C star, which we've taken dozens and dozens of images with. It has a dual, well, we'll talk about it, a dual narrowband filter that targets both the hydrogen and the oxygen lines and ignores the sulfur.
Which, if you're going to target two, those are the two.
If you're going to target two, those are the two, because sulfur line obviously is not even very strong in the Ring Nebula.
Yeah. So is there a rule of thumb when choosing objects and determining which filters to use?
Yeah, so my knowledge of spectra of emission nebulae is derived largely from Richard Walker's book called The Spectral Atlas for Amateur Astronomers. It's a wonderful book. It's beautiful. But based on the few nebulae that he's taken spectra for in that book, the rule of thumb would be if it's a diffuse nebula like the Orion Nebula or the California Nebula, don't bother with sulfur. If it's a planetary nebula, you might get some sulfur. And if it's a supernova remnant, especially a young one like the Crab Nebula, you're probably going to have some sulfur. But in all of them, I mean, all nebulae that we've encountered will have hydrogen and oxygen. So if you're going to buy two narrowband filters, buy those two, or buy a dual band of both those two. There is an exception to that, and that's Rosette. We got a fair amount of sulfur in Rosette, remember?
Yeah, I remember.
And we used Rosette as the cover of our book. It might be our proudest image, but Rosette is a bit of an exception of the diffuse. It is a diffuse nebula. It's a bit of an. It certainly obeys the idea that it's photoionized by several hot stars in its core that are hollowing out the core. But these stars are really hot, and they're heating the gas to millions of degrees instead of tens of thousands of degrees. And I think it's that shock wave that produces some sulfur in Rosette. So it's kind of an exception.
Okay.
Yeah.
So you're saying there's not a hard and fast rule.
No.
So I have to go and check out Astrobin and see what everyone else does.
Yeah, and that's kind of what we do. We see what everybody else did, and then we copy what they did.
Throw a little hydrogen alpha in our Andromeda, and
and so Rosette kind of is masquerading like a supernova remnant. It is a very violent. I mean, there's an expansion. There's stellar winds that are hollowing out its core. I don't know. We love Rosette. Rosette is just super, super beautiful object. Yeah.
All right. Principle 89, dual narrowband filters. Dual narrowband filters have two pass bands, targeting the hydrogen alpha and the oxygen 3 lines.
Yeah, so the spectrum might look something like this, come down to 0, and then target this one up here. You can get it with different bandwidths. I think the C-star, the dual band, they call it a nebula filter in the C-star. I think it has a bandwidth of something like 10 nanometers or 15 nanometers wide for each of the lines. The other thing, and we talked about this in a previous video, the Crab Nebula, these lines, the oxygen 2 lines, oxygen 3 lines here, sorry, are Doppler shifted. So the light that's coming from the front of the nebula is coming, the part of the nebula that's closest to us is coming toward us, and blue shifted. That's this line right here. And then on the back side of the nebula, it's moving away from us, and red shifted. That's this one right here. And the implication is that if you're using all these filters, the S2, the hydrogen alpha, and the oxygen 3 are 5 nanometer chroma filters, but you're going to throw the baby out with the bathwater if you use 5 nanometer filters to try and do the Crab Nebula, because, I'm sorry, you'll get a lot with a fair amount of light with 5 nanometer filters, but if you use 3 nanometer or 2.5 nanometer filters, like what we have, the spectrum of the filter, the transmittance curve, is pretty much going to miss those two peaks. So thanks so much for watching.
And we'll see you next time.